Right, this question here is all about working with angles and sides and triangles. Now, a question like this, typically in a calculator paper, what we're looking at using is we're either looking to use the cosine rule or the sine rule. Now, you can quickly and easily identify which of the two of them you're using by looking for pieces of information that you're given and or working with in the question. If you're given two sides and the angle between them, or you're working with all three sides of a triangle, that typically leads towards using the cosine rule. If you're working with sides and angles opposite one another, that will lead to you working with the sine rule. Now in this question, I've got the information illustrated in the diagram, and I want to calculate the size of the angle JKL, which is this angle here, which we're going to call X from now on. Now if I look at the diagram, you'll notice that in the diagram, I have angles and sides that are opposite one another. Because I have angles and sides opposite one another, my brain should instantly think sine rule. Now, sine rule, we're quite lucky in that it's given in the formula sheet. So the sine rule says A over sine A equals B over sine B equals C over sine C. So what it's fundamentally telling me is that the ratio of the side and the angle opposite each other for all three angles and sides in a triangle is the same, which is where the sine rule comes from. Now in this question, what I'm going to do is I'm going to label each of the sides and angles that I'm going to use. I'm going to just stick to using the first two parts of it. Yes, there's three parts to it, the sine C as well, but I'm just going to stick with using sine A, sine B, little a and little b. So what I'm going to do is I'm going to name the angle that I'm using as big A, the side opposite is the little a, the angle that I know is big B, the side opposite is little b, and then I'm going to plug that information into the sine rule. So I'm going to end up getting is that 10 over sine x is equal to 7 over sine 25. Now what I want to do is I want to rearrange this equation so I get sine x is equal, and I can then solve it by taking sine minus 1. So if I quite simply cross multiply both of these, what I'll end up with is 10 sine 25 is equal to 7 sine x. So again, if I rearrange that again by dividing by 7, I get that sine x is equal to 10 sine 25 all over 7. So now that I've got that, I can simply say that x is equal to sine minus 1 of that. So it's sine minus 1 of the 10 sine 25 all over 7. And at this stage, we can just use our calculator to calculate the solution to that. If we take that information and plug it into the calculator correctly, what we'll end up getting is an angle of 37.1 degrees. So there you go. The angle at x is 37.1 degrees. So we can then state, therefore, JKL is equal to 37.1 degrees. Job done. Once the angle at that point, we're giving it the angle at that point. This question is worth 3 marks. We get 1 mark for setting up our sine rule. We get a 2nd mark for rearranging it to get sine x equals. And then 3rd mark for the actual solution itself at 37.1. They wouldn't penalise you if you rounded it to 37 and went to a full number for the angle. So this sort of question here, the key thing, that first step, identifying which of the rules we're going to use. When we're using triangles with angles and sides, and it's not a right angled triangle, just start thinking of the cosine rule and the sine rule. Then we have to identify which one to use, and we know the properties we're looking for to be able to determine which of those two rules to use. We're looking at sides, angles, their position in relation to one another, and how we can bring all that together. If you're able to do that and identify effectively which of the rules to use, using them is just following steps of algebra. Something we've done for a long time and something you should find fairly straightforward, easy peasy, lemon squeezy.